In this session I want to talk about the elasticity formula. So we're just going to concentrate on the formula and how to manipulate the formula. So it's just a session about a very simple equation, very straightforward equation. First of all, we need to note that we measure elasticity with the Greek letter eta, which looks a little bit like an N with an elongated tail. So a little bit like an N. So we use, like much of mathematics, we use Greek terms. But eta is what we use for elasticity. Now let's start. The elasticity is measured by that formula, which may look a little bit daunting to you if you haven't seen this before. But first of all, we've got eta. I'll just put the cursor onto the slide so we can talk about it. There we go. So we've got eta, which is elasticity, and that's equal to. Now if you read this properly, if you read this across, it's actually very straightforward. So it's equal to the percentage, and this triangle here means delta. We use another Greek term, but we use this in mathematics to show the change in something, the change in a variable. In this case, the change in Q. So that delta, the triangle there, delta, that simply means the change in. So don't read it as delta and don't read it as a triangle, certainly. Read it as the change in Q. So if we read across here now, we've got the percentage change in Q. If I can just say that normally, it becomes the percentage change in Q. So it's just the percentage change in Q on the numerator. Likewise, on the denominator, we've got the percentage, this delta again, change in. Just read it as change in. Percentage change in P. The percentage change in P. So what we've got here, two percentages. That's all the elasticity formula is. We've got elasticity, eta, is equal to the percentage change in quantity divided by the percentage change in price. So we've got 1% up here divided by another percentage down here. So when you divide two percentages, you just get a number. If you divide 10% by 2%, you just get 5. There are no units. And that's important because elasticity does not have units. Elasticity is just a number. So that's our formula. Elasticity is equal to the percentage change in quantity divided by the percentage change in price. That's what you've got to know. And as I said earlier, put the cursor back, if prices, let's say, increase by 2%, the percentage change in prices, let's say that goes up by 2%, plus 2%, the demand might fall by 10%, minus 10%. So the percentage change in quantity is minus 10%. So you've got minus 10% divided by 2%, which is just equal to minus 5. When we deal with elasticity of demand, we invariably get a minus sign because demand curves slope downwards. There's an inverse relationship. So as one increases, the other decreases, which gives us a negative sign. So we ignore the minus. Convention is we just ignore it. So in this case we'd say that the elasticity of demand is equal to 5. It's the absolute value we're worried about, the absolute value we take, the modulus of the number. So we take minus 5, it's the same as 5 to us. So the percentage change in quantity divided by the percentage change in price equals minus 5. Now let's go back to our formula again. We know now that the elasticity, eta, is equal to the percentage change in quantity divided by the percentage change in price. So if we look at this in a bit more detail, put the cursor back. Here, if we're going to work out a percentage, what we do is we take the change in quantity divided by the quantity, multiply by 100. That's how you work out a percentage. You take change in something divided by the total amount, multiply it by 100. And that's all divided by the change in price. Remember, delta here, the triangle means change in. The change in price divided by the price times 100. I haven't done anything really. I've just told you how to work out a percentage, which is what you did when you were in primary school, I guess. So we have the change in quantity divided by quantity, that fraction multiplied by 100 gives us the percentage. And this one down here gives us this percentage. So we've still got just two percentages, one percentage divided by another. However, we can tidy this up a little. We can get rid of the hundreds for a start. 100 on the numerator, 100 on the denominator gives us just simply this expression, eta, elasticity of demand, is equal to the fraction, the change in quantity, divided by the quantity, all over the change in price, divided by the price. So on the numerator I've got this fraction, this one here, oops, sorry, I've got this one, and on the denominator I've got this fraction here. So that's all I've got. I've got two fractions. I'm dividing one fraction by another. And if you remember back to early school days, when you divide one fraction by another, you simply turn the denominator, this one here, you turn it upside down and multiply. And there it is, upside down. This one here, turn it upside down, oops, again, turn it upside down and multiply. So we have this one here, which is here, and this one, which we turn upside down and multiply. So we've got this expression here. We just tidy that up a little bit. We take the delta Q over the delta P, just move this one across here, just move it, shunt it across. We'll take the Q here and take it across here. So we've got delta Q over delta P times P over Q. And there we've got it. We've got just the same formula written in a different way. And this is the way here we would mostly calculate elasticity. It normally comes in this format. So we're given information, we slide it into this type of formula which does the calculation for us. If we are fortunate enough to be given percentages, we'd use this one up here. Otherwise, if we're given figures, we can just multiply, we can just work it out on this one here. Well, that could be an exercise for a class, for example, working out an elasticity. Okay, that's an introduction to elasticity, just the formula for elasticity and how we'd manipulate it. I hope that was of some use. So we've got two formulas in the end. Well, actually we've got one formula, but we've got two versions of it. So I hope that was of some use, and there'll be some more classes in the elasticity series which will further elaborate on this lot. Thanks for watching.